Hi, welcome to Introduction to Aerodynamic Objects Tutorial 5, Get Ready to Fly. And in this tutorial we're going to add a wing to the weather vane to create lift and understand aerodynamic balance and stability. We're going to take our weather vane model from the previous tutorial and add a wing to it, and then we're going to adjust the pitch angle of the horizontal stabiliser to achieve balance at positive lift. Then we're going to set the centre of mass using a marker object, an aircraft manager script. And finally, we're going to move the centre of mass around so we can understand the effect of that on aerodynamic balance and stability. This is our scene diagram, pretty much the same as it was for the weather vane, except this time we've now got a wing on there. So we've got a vertical stabiliser, horizontal stabiliser and a wing. We've also got a very simple script attaching to our top level object that allows us to set the centre of mass. So here we are in Unity. We're pretty much exactly where we left off at the end of tutorial 4. So we've got our weather vane model in here. And what we're going to kick off with is just creating a wing for this. And because we're lazy and smart, we're going to do the smart lazy thing and produce a wing just by duplicating the horizontal surface. So I'm going to go on the horizontal stabiliser, Control D to duplicate, let's call it wing. And let's just drag it across to the middle. In fact, let's just put it exactly in the middle on the 0, 0, 0. There it is, a little stubby wing in there, and let's rescale it to just make it bigger. Doesn't matter particular what size it is, but I'm going to click on the geometry, and to do this I'm going to use the rescale tool. So you hit R on the keyboard, or you can select it there. And I'm just going to stretch it out so it's about 6 meters span and about a meter in chord. Okay, it doesn't matter exactly what shape it is. So we've got a wing, we've transferred everything else across. Great thing about aerodynamic objects, if you created something and duplicate it, it's just another aerodynamic surface and it's all handled for you. We've got our wind uniform flow set up here. Let's see what it does. And kind of does nothing, and the reason is we've made a weather vane, it's pointing into the wind, our wing is exactly in line with everything else, so this thing is balanced at with no lift on it. And if we change the wind direction, so the wind is now coming from up there, the thing changes its angle and you get a little bit of lift in the interim, but then eventually just points straight into the wind. And if I bring that back down again, it's there slowly pointing into the wind. We're getting some lift there, but that's because it's not quite balanced yet and it's swinging into the wind. It's doing it quite slowly. We've only got the speed on at 1 meter per second and this is 5 meters long, so we're seeing everything kind of in slow motion, real physics time. Okay, so how do we make this so it balances at a positive lift? So what we want is that when this thing settles down, it's flying along with the wing generating lift. And you can imagine one way we could do that. What we need, when instead of the weather vane pointing directly into the wind, if the weather vane points slightly nose up, then that's going to mean the wing's at an angle when it balances, and that means the wing will be producing lift. So how about we try doing something to push down on the back of the aircraft to make the nose go up. And so if we go to our horizontal stabiliser, I'll need to use the geometry transform for this. And if we want to rotate this, y-axis there is going that way, so what we want to do is rotate that surface about the y-axis, and if we can angle that surface leading edge down, that's going to be pushing on the back, and then hopefully it's going to balance with the wing at an angle of attack. Okay, so we go up to the y-axis there, so I'm rotating it down, and just like that, what we've done is now balance our aircraft in such a way that when it's pointing into the wind, it's pointing into the wind with the wing at an angle, and we're generating lift. So if we let that go now, that would generate some lift when it was flying. And this is an aerodynamic balance, it's not a gravitational balance. So if we change the direction of the wind, the wind's coming from up there, the thing adjusts its angle, and when it settles down, it's at the same angle of attack as it was before. So the angle between the plane of the wing and the wind vector is around, I don't know, 15 degrees, and so we're flying up, but we're at an angle of attack around 15 degrees. And yeah, just to show that again, if we take that off, come back again, when it eventually balances, it balances at the same angle of attack. Great, so it's simple as that. To make an aircraft balance in flight so that there's lift on the wing, you need some sort of downforce on the tail, or some sort of nose up pitching moment, so when it balances it's flying along with the wing at a positive angle to the wind. Next up, let's have a look at what happens when you vary the centre of mass position. And if you remember from when we built this, our rigid body is on the rod, and we can manually set the centre of mass using these coordinates here. It's a little clunky doing that, so what we're going to do is give ourselves a visual tool for the way to do it. And first off, we're going to put a marker on there for the centre of mass. So I've gone to my prefabs, all prefabs. If I just drag that on top of the rod, and it's come in there, and we've got a centre of gravity symbol. And what I'm going to do is actually just put it visually underneath the rod there. Just for me, it should come straight underneath the rigid body. And the other thing I'm going to do, it's a prefab, but once it's in, we're not going to refer back to its original again. So I'm just going to right click on that, go to prefab and do unpack. So that just kind of breaks the connection with the other one, and it stops it being dominant blue in your hierarchy. So that's just a graphic blob. What we're going to do is have a very simple bit of code that just takes the position of that graphic blob and moves the centre of mass of our rigid body to that position. So if we do add component, and then what we want is aircraft manager tutorial 5, and that's already come up for me. So if I'm searching for aircraft manager 245, and it's asking for a reference to the centre of mass marker, so I'm just going to drag that in there. And all this does is wherever we put the centre of mass marker, it will change the centre of gravity to that. It'll not only do it in edit mode when we're running the application, we can also move the centre of mass. Okay, and then before we try this, what I'm going to do is just dial in a little bit of tailplane deflection. So I'm going to put in there at -5 degrees, just so we can see something happening straight away. So you can see that's tipped down 5 degrees there. Centre of mass is at 0, 0, 0, so basically that's the middle of the plane. Now let's just see what happens. Okay, so that's kind of what we saw before, but now let's have a go at moving centre of mass marker. So if I now bring it all the way to the front, what we have there is an aircraft that's really stable, so it's pointing into the wind, and actually because it's really stable, it's harder to balance. And then if we start moving it back, so that's where we had it before, so that's good for balance and it's stable. But if I carry on moving it back, it's kind of slipping off the plane slightly. Put it right back there. What we find is the plane is now unstable in pitch, so it's actually going backwards now. That's the front, the wind is coming that way. We've moved our centre of mass sufficiently far back that the plane is unstable in pitch. So let's move it back somewhere sensible. Move it forward again, and our aircraft is stable. Okay, so that pretty much finishes this tutorial, and what we've seen is if we're building up a plane with a wing and a tail on it, to make it balance in flight, what we need to do is alter the angle of the tail. So in this case we had to rotate it with the leading edge down, such that when it balances in flight, it balances with positive lift. The other thing we saw is that centre of mass is really important, setting that up, and if you have the centre of mass really at the front of your aircraft, it will be really stable, but it makes it harder to balance. If you have the center of mass somewhere in the middle, that's okay. But if you have the center of the mass really far back, then that means your aircraft is going to be unstable in pitch. And in the next tutorial, my first glider, we are going to take this little plane off its training wheels or take it off its gimbal and allow it to fly in free space. So hopefully see you there.